Section 12.6, multiplying and dividing monomials. So we've done adding, we've done subtracting. We are now ready to multiply and divide, just like elementary. Alright, just a reminder, when we do exponents, we're talking about repeated multiplication. So, if we have 3 squared, that meant 3 times 3. Or if I have 3 to the 4th, that meant 3 times 3 times 3 times 3. So what we want to do now is talk about, well, what happens if I multiply those terms together? So here's my first term, 3 times 3. Here's my second term, 3 times 3 times 3 times 3. Altogether, there are 6 3's. So 3 to the second times 3 to the 4th gives me 3 to the 6th. So if we want to multiply, notice that what this did was add those numbers right here. So when you are multiplying exponents, you add them. Okay? So let's take a look down here at the key concept. To multiply powers with the same base, now that's important. They both had 3's. That's their base. You add the exponents. So 2 to the 4th times 2 to the 3rd is same as 2 to the 4 plus 3. 2 to the 7th. And this works for any term. So whatever this is, whatever a is, whether that's a number or a letter or anything, to the power, if I multiply it by the other thing, same base, notice that's the same thing, a and a, I can add those together. So I can add those two terms together when I do that. Okay, so let's do a few problems here. Multiplying powers. First question, first problem, 5 squared times 5. Now, think about this. If I have 5, what power is that? Well, 5 just by itself is 5 to the 1st. So I have 5 squared times 5 to the 1st. And remember, we add exponents. 5 to the 3rd. So that's my final answer. I skip something? I did. Yeah. Okay, now this one's a little more complicated. Let's say we've got negative 3x squared times 4x to the 5th. Well, alright, what we want to do is we want to work with x terms and we want to work with numbers. And we don't want to kind of mix them together too much. So let's do the numbers first. So let's take a look at negative 3 and 4. Now, remember when you're multiplying, it doesn't really matter order. Good old, what is that? Commutative property. Doesn't really matter how I put them in there. They all are the same. So I can just say, well, let's think of negative 3 times 4. And then that leaves me x squared times x to the 5th. So negative 3 times 4 is negative 12, and x squared times x to the 5th, remember we're going to add those exponents, 2 and 5 then makes 7. So my final answer is negative 12 x to the 7th. Alright, you guys try these. Pretty easy. See if you can do them. Stop the video, put them in your notes right now. Okay, so you should have gotten 9 to the 5th. We just add exponents. Here, we would get y to the 13th. This one, a little more complicated. We would multiply the two numbers together. We get positive 16. Negative 2 times negative 8, positive 16. M times m to the 5th would be m to the 6th. Now, we can also divide powers. When you divide, so here I have 3 to the 7th divided by 3 to the 3rd. When I divide, I subtract those numbers. So 3 to the 7th divided by 3 to the 3rd would end up at 3 to the 4th. So over here, it's going to end up being a m minus n. Now, you cannot have a equals 0. Why? Because you can't divide by 0. So that's one rule. You couldn't do it to a 0. 0 to some power is still going to be 0, so you couldn't do that. All right, let's take a look at this first one. 4 to the 8th divided by 4 squared. Now you could multiply all that out, but wow, way too much work for that. So we're just going to subtract 8 minus 2, and we're going to get 4 to the 6th. Easy. Okay, here, subtract. Subtract your exponents. N would be n to the 5th. Okay, all right, easy. Try these. All right, hopefully now that you're done, you find that these are pretty simple. 5 to the 3rd. This would be x to the 7th. And here you've got two things. You got to divide the 12 and the 2. Well, that's easy. That's 6. W to the 5th. Now, there's nothing here, but that means it's a 1. So don't forget it. W to the 4th. All right, let's take a look at this very last example here. Sound. The loudness of a conversation is 10 to the 6th times as intense as the loudness of a pin dropping. So right now, what you're hearing is about 10 to the 6th times greater than if I dropped the pin on the floor. While the loudness of a jet engine is 10 to the 12th times as intense as the pin drop. How many times more intense is the loudness of a jet engine than the loudness of a conversation? Well, okay, 10 to the 12th times for the jet engine, really loud. 10 to the 6th for conversation. We would now subtract. We would end up being 10 to the 6th times more powerful, which is 1,000,000 times more powerful. By the way, this scale, what they're talking about here, is often called the decibel scale. So when you have something that has so many decibels, that's what they're talking about. And the decibels are based on powers of 10. So if you have something that's 1 decibel of 1 versus a decibel, 2 decibels, it doesn't mean it's just twice as big. It means it's 10 times. You've changed the power. So just a little added information for you there. I think hopefully these are pretty straightforward for you. So I think you're good to go on this particular section here. So go ahead and get started.